assume that R is less than or equal to 1. Why? What happens if R is 1? If R is 1, then consider the value W1 plus T. What is the value of W1 plus T? The first one is the absolute. The R is equal to 1. So this is 1. This is 1, and this is minus 1. And this is also 1. Sorry? Oh, absolute value of A1, but A1 is equal to 1. So this value is 1 and 1. But it is greater than 1, 0. And 1, 0 is a unit element of this product group. So please recall our condition on super spy. So we need the condition VA is less than or equal to 1 for A in A plus. And this T is of course in VP bracket T. And this one means a unit of gamma. So in this case, this one is actually this one 0. So this valuation doesn't satisfy the condition. This condition. So this is not in D1. But we change the sign. Then this one becomes a minus 1. And this is less than 1, 0. So double 1 minus is an element of D1. And more interestingly, we can prove that double R plus and double R minus is in the closure of double R. This and this is in the closure of this. So actually this is not a closure point. And these are closure points. And these rise in so these are specialization of this element, these points. So in particular, for A in QP with absolute value less than 1, the rational subset T over A. This is very roughly speaking the subset, this subset. So I defined it before. This is open, but not closed. Okay. So by this argument, we know that AA absolute value and AA absolute value minus is in RT over A, but plus 1 is not. Plus 1 is not RA over T. So if this is closed, then the closure of these points lies in this space. But this point is this point is in closure of this point. So this is not closed. So in fact we can prove that the boundary of this subset, namely the closure minus RT over A itself, consists of 1 point double plus. So it is not closed. So therefore, D1 is not totally disconnected. D1 is not totally disconnected. So classically, the disk in a smaller disk in a disk is open and closed. So this space is totally disconnected. But after adding some strange points, then this space is not totally disconnected now. So such a point glues this region and this disk. Yeah. And I shall give another example. So super VP. This is very similar to spec VP. Actually, it consists of 2 points, S and eta, where S is a variation on VP obtained as follows. So first, take modulo P map to go to FP and consider the trivial variation on FP. Trivial means that if A is equal to 0, then it is mapped to 0, and otherwise it is mapped to 1. This is S. The support of S is, of course, PZP. On the other hand, eta is more natural one. Eta is simply first embed VP to QP and take a natural valuation to R greater than 0. Then the topology is very similar to the spec VP. Namely, topology is S is closed and not open. This is a unique topology. This determines the unique topology on this. Namely, eta is open and not closed. And so S is a closed point, and eta is a generic point, generic open point. Okay. Yes. So far, I define the underlying topological space. So I should define some structure shift on this space. Structure shift. It is yes. Okay, I will define the definition. So let A be a affinoid ring, and take I and A0. So A0 is a ring of definition of a triangle, and I is a finitely generated ideal of definitions of A0. And so for For rational subset of super A. So I want to define the section of structure sheaf on this rational subset. So this should be some ring written as this way, T1 Tn over S. So what is this? This is a completion, actually a completion of a triangle S1 over S with respect to the topology generated by such one. So A0, T1, Tn. This is the definition of structure, the section of structure sheaf. So this ring doesn't depend on T1 and Tn, but the topology does depend. So this depends on this rational subset. And actually also a priori this depends on the choice of T1 and Tn and S, but we can prove that this ring only depends on this subset and independent of T1 and Tn and S. So if we change this T1 slightly, then for example, if we change this T1 slightly, then this subset doesn't change, but then this ring doesn't change. Yes.
In this case, you take any ideal I.
Yeah, any ideal and any A0. But it is independent of this is independent of the choice. Yeah. And yes, and we have another ring because Adic space has affiliated ring with a pair of rings. So we have another kind of structure sheaf called O plus. This is a plus T1 Tn S, but I will skip the definition of it. So it is naturally defined by using a plus and this construction. And the problem is that this O whether this O becomes a sheaf or not. And actually, it is we cannot prove that so so we should put some restriction on this A to make this O a sheaf. This is a theorem. This O and O plus are sheaves of complete topological ring on super A. If a triangle has Newtonian ring of definition or a triangle is strongly Noetherian and Tate. So we need the condition. Yes?
When you define super A,
Super A? Yeah, by variation, but the variation group of variation can depends on the variations, and we consider all variations on this A. Yeah.
What it means strongly?
Oh yeah, I will explain, of course.
You said it. In your student, O plus is CS, coherent C, locally free.
Coherent or locally free, that doesn't make sense unless we fix a ring of structuring, and we want to define. You mean a coherent? Yeah. I see. Yes, I think under these conditions we can prove that this is coherent.
Maybe sometimes it can be locally free. I'm not sure.
Sorry, this always locally free on module. Of course.
How about O plus also? I'm not sure.
O plus is not O module. This is an integral structure of O. Yeah. So this corresponds to the second argument of second one, A plus, A triangle and A plus. So. Yes. So definition of strongly Italianness is the following. This is for every n, the convergent power series of a triangle is Noetherian. It is a kind of Hilbert's basis theorem, and actually it is known that if K is non-Archimedean field, namely field with valuation of height 1 with valuation topology. Topology is defined by this one. Then this ring is strongly Noetherian and Tate. So of course if K is complete discrete variation ring, then the first condition ensures that O is a sheaf. But even if K is not discrete, the variation of K is not discrete, then the second condition ensures that O is a sheaf. So the typical example is K is CP, the completion of the algebraic closure of QP. This is completion of the algebraic closure of QP. Yes. So we have defined the structure sheaf on super A, and it has more structures. For every point on X carries a natural valuation Vx. So please recall that a point of super A corresponds to the valuation of A, and it in this is a valuation on this stock on OX. this is another structure. And we know that OX is a local ring. We can prove that OX is a local ring with maximal ideal support Vx. So support Vx is the maximal ideal of the unique maximal ideal of OX. And OX plus is integral structure of OX, namely a ring of integers in some sense. Namely, the value of Vx is less than or equal to 1. But OX is not a variation ring. So if we divide this OX by this support, then it becomes a variation field. And this is called residue field. Okay. Anyway, we can consider the variation on the stock. So finally, by gluing this all of these, we can get a notion of adic space. So let V be the category of triples. Triples X, OX, Vx, X, and X, consisting of the topological space X and OX is a sheaf of complete topological ring, and Vx is a variation of OXX, the stock of OX. And what is the morphism in this category? The morphism is X to Y. This is a morphism of topological ring space, namely the continuous map. And we have the pullback map on the sheaf OY, F upper star OY to OX, map of topological ring, map of this and this, such that the valuation is compatible with this map for every X in X. So we have a mapping from OYFX to OXX, and this ring have a valuation gamma. So gamma union 0. This is Vx, and this is Vfx, and this is induced by F, and this commutes up to equivalence.
Derivation of the derivation of the 2 points, the previous and immediate, the common target.
So yes, after changing in the equivalence class. So precisely we have a variation on this and different group, and we have isomorphism under these two groups, so that the diagram commutes. Yeah. Finally we can define the adic space. So definition, adic space is an object of V, locally isomorphic to super A for some affinoid space, affinoid ring A. And the adic space isomorphic to not locally but actually isomorphic to super A is called affinoid. And finally, I mentioned something. So remark is that if we put O plus or OX plus, sorry, let X be an adic space. And define OX plus, which is a subsheaf of OX, so that OX plus, the section of OX plus is the section of OX such that for every X in U, the valuation is less than 1. Then we can recover the plus sheaf. Can recover O plus. And finally, the important thing is the in some sense, categorical equivalence of affinoid algebra and affinoid. So let A be an affinoid ring and X be an adic space. Then the homomorphism from X to super A is naturally identified with the continuous map from a triangle A plus to the pair gamma X OX plus. So in particular, for if X is affinoid, namely, so let B is a complete affinoid ring, then the homomorphism from super B, super A is naturally identified with the continuous morphism from A to B. So there is a natural categorical equivalence between the category of complete affinoid rings and the category of affinoids. So this is an this is an analog of theory of affine schemes. So in the theory of adic